My name is Sara Al Maeeni from Mohammed bin Rashid Space Center, and I'm here today to talk about the Emirates Lunar mission. So I'll skip some slides and talk about the mission. So the mission consists of a small rover called the Rashid rover. This announcement was made in 2022. We had different primary objectives. The first one is to have the technology demonstration of building a rover for the moon and do some fundamental science that will help us in understanding the geology of the moon and will help us in future missions. Also, as like secondary objective, we had to attempt to survive the night and do some public engagement during the operation of Rashid rover. Talking about the fundamental science, we wanted to understand the soil surface properties, to understand the altering processes of the lunar surface and understand the big question of what is the formation of the Earth and Moon system. Also, we want to understand the plasma environment and especially the electron sheath, the vertical distribution of the electrons at different heights, and understand the dust transport from a place to another. From engineering aspects, we were doing we had one experiments called material adhesion determination experiment. Where we wanted to understand what is the interaction between the soil, the regolith and different materials. And this was based on one of the experiments we did on the wheels. For the mobility, we wanted to understand what is the interaction between the wheels in terms of syncage with the lunar regolith. To fulfill all these science objectives, we had different science instruments, starting from the Langmuir probes that we have on different heights on the rovers. We have also thermal cameras to understand the thermal behavior and of the rocks and the boulders. We have two cameras. The cameras, of course, will used first for the navigation, but also will be exploited scientifically. We have also microscopic camera. The resolution is very high, can go down to -30 micrometer. And finally, the material samples here on the wheels that you see here that conduct the experiment with the lunar regolith. Of course, the rover went through different testing and verification, qualification, starting from mobility, communication, drive-off, environmental, consisting of thermal, of vibration, and finally with the integration with iSpace lander. So the plan was set to launch in 2022, as you saw last year. And it took around 4 years of trajectory to be on the moon. And unfortunately, on 25th of April, a crash landing happened. We didn't deploy in the moon, but there is a real success that lies between the missions where we had a numerous collaboration with agencies, research centers, and entities around the world. For the science itself, you can see from here that it's more than 15 entities. We had this collaboration. And of course, from other aspects like the landing site, ground network support, we had other collaboration. So for the first one, it was landed on Atlas crater. More information about the geology of this Atlas crater will be given by our colleagues from CRPG tomorrow. And what is next? So next is South Pole, of course. It will give us the opportunity, as you know, to access this permanently shadowed area and maybe we can find some, we can see the presence of some volatile substances. So the plan is like as the follows: it's planned to be at Q4 2026 to have the flight model, maybe to launch on 2027. We will have also again a commercial lander. The science again to do some water prospecting, and the duration is 50 days. So the strategy is to chase the light, chase the sun, and fulfill this objective. The mass is somehow same. It's still a small rover. It's around 25 to 30 kg. So I made it very quick, and this is from my side. Thank you.